Ladies and gentlemen, today's topic is OpenMMT for summarization. We are today's speaker. I am the master student from National Taiwan University, and this is Paul from Ubiqus and Loom. And okay, let's get started. What is text summarization? Text summarization is an important text in natural language processing. The challenge is to capture the core information of a document and create an informative but brief summary of the document. For example, book summaries, scientific abstract, and article headlines are all text summarization applications. Study of automatic summarization can be roughly separated to two approaches, extractive and abstractive. Extractive approach selected keywords or sentences from the original text, then arrange them to form a summary. Briefly, extractive approach is a scissor. Cut and move parts of the text. The other one is abstractive approach. Abstractive approach learns an internal language representation from the original text and generate a more human-like summary. Abstract approach is a pen. You read a long text and now you write a short, compact version of it in your own words. There is a breakthrough in abstract approach with the development of neural networks. Today we will focus on neural networks for abstractive summarization. And this slide, we introduce how to automatically evaluate the generated summary. Rouge is a widely used evaluation matrix. Rouge measures the quality of a memory by computing overlapping units between an system-generated summary and a reference summary. Most of studies report 3 score. Rouge 1 is mainly considered informativeness. Rouge 2 and Rouge L are supposed to be linked to readable. However, Rouge is not the best way of automatic evaluation because we cannot have a single perfect summary. Rouge only represents that the generated summary is overlapping to the reference summary. But it is still the better and the convenient one nowadays. And the next Paul will talk about neural networks for abstractive summarization and the English summarization text.
Thank you, Scott. Maybe we could switch. So as for neural machine translation, like the performance of abstractive summarization has been greatly improved by the rise of deep learning and more specifically sequence-to-sequence learning. So I guess I'm not the first one to talk about sequence-to-sequence learning today, right? But we still be quite fast on it. Basically, the idea is to map a variable length input into a fixed length vector, which will be the context. This part is the encoder, and to use this context vector into a second part, the decoder, in order to generate the output sentence. So basically, usually we use RNNs for both those parts, and in each case we use one single vector, which is the C, which appears here and here. So at each decoding step we use the same context vector. And in practice this can be limiting because it forces the model to map the entire input information into one single context. And that's the idea behind attention mechanism. So this model is basically an improvement of the previous one. The first thing we had is that we use a bidirectional encoder so that we capture both information about previous words and next words. And then at each decoding step, we will compute a context vector by applying attention. So the idea is to get scores at each time step, which will represent how relevant an input is. So we want a representation that is really adapted to a given time step and not the whole sentence. So in this case, applying a softmax to get a probability distribution, we can use this probability distribution in order to create a new context vectors that will depend on time, and which is a weighted sum basically of the attention scores and the input states. And so we can generate at each time step something based on a more contextual context, if I may say. In order to see what this alpha means, as we already seen, we can see this attention matrix. So basically here, the whiter the cell, the more attention is focused on a source. So in this case, it's English to French summarization. So basically, we see that the attention mechanism will learn to align the source sentence with the output sentence, and we can see an interesting pattern, which is diagonal in the opposite direction, which shows that this attention mechanism can learn that, for example, in French, the order is not the same that in English. You have to put the noun first, etc. So we show that this attention mechanism could learn semantically, like grammatically interesting parts. So this has been applied for abstractive summarization in the case of sentence. And basically at this point we have two problems. The first is that we are using a limited vocabulary, and increasing the vocabulary size is quite expensive, both in the encoder and the decoder. And the other problem is that we have repetition and problem of coverage. Basically, our model learns how to focus on one part of the text, and it keeps talking over again about this thing. So we have results like this when we apply it on longer sequence that are not relevant and not usable at all, because our model keeps talking about the same thing. One solution for it is to apply a kind of temporal attention. The idea here is to get an attention history by summing the previous attentions, and to lower attention given at the next decoding step by this history. So this approach can be said to be destructive, since we directly act on the attention scores. Another approach, which is informative, still use the same kind of attention history, but instead we won't tell the model how to use the history. Instead, we will just feed this information into the model, and hopefully it will learn that you need not to repeat and to cover a wider variety of subjects. Another techniques which has been mentioned is the coverage penalty. I mention it here because it's what it's implementing currently in OpenNMT, but we may say that it's not really relevant to summarization. Basically, the idea is to focus on different parts of the text. So to have for each source to have one high attention score, so that it will cover the whole source. But that's not really what we want in summarization. We want the summarization model to be able to skip some parts, because some parts are not really relevant. The last attention model to resolve this is a double attention, which use both a temporal attention, as we've seen, and a quite new technique that is attending on past decoding steps. So instead of attending between the decoding step and each of the encoder state, we will attend between still the decoding step and previous decoder state. So it will, like this part, it will focus on coverage, so covering a wider variety of subject, and the second part is more to avoid repetition by considering past translation generation, basically. The second problem that I mentioned is the problem of vocabulary, which is quite uniformly addressed in the state of the art. So the idea is to have a pointer generator, which is called also a copy mechanism, that would directly point a part of the source and use it as is in the summary. That particularly makes sense in our case, since we use the same language for the source, and the target sequence. Finally, a technique that I've been working on using OpenNMT is a reinforcement learning for abstractive summarization. I'll be quick on that because we're running out of time, but the idea is to generate two sentences, so two prediction, to compute the rule score of those two predictions, and finally to favor a sentence that has a high rule score. So I do not have time now to go into detail, but basically this is what we always do in summarization, and this is a path that is more like an inference one. So we try to increase the probability of this sentence if it has a good rule score. So the result quickly on abstractive on the gigawatt dataset. So basically, both techniques on OpenNMT are quite good. We are better than the state-of-the-art result on summarization, which is quite good. And there is no really recent work on this dataset, but instead we are working on the CNN Daily Mail dataset that has way longer sequences, like multi-sentence sequences, which has to use both coverage and copy mechanism. So the baseline of OpenNMTPy is this one, which is quite lower than the state of the art, but it's a baseline. We're still working and getting better result day to day. And that's the part that I implemented with the reinforcement learning and intro attention, which is getting better scores than the baseline, but still less than what has been published. And basically that's an example because root scores aren't really intuitive. This is a kind of result that we have. So rapidly we can see this is the prediction. So it's correct English, it's quite relevant, and that's quite the thing. It's okay, but it could be better.
Talk about Chinese summarization text. Due to the language property, there are some obvious difference between English and Chinese summarization text. In English, we usually use a word as a basic unit which contains semantic meaning. Chinese is very different from English, especially in word segmentation and characters. Chinese words are usually composed of 1 to 4 characters, and there is no explicit delimiter between words. And since Chinese character usually contains semantic meaning, many studies use character-based representation instead of word-based to keep out the error introduced by word segmentation and out of vocabulary problem. For example, a Chinese sentence 我今天很开心 can be separated to character like here, and it also can be segment to the word. And in Chinese summation, most of study use this data set LCSTS to do research. LCSTS is short for a large-scale Chinese short text summarization data set. The articles are collected from Xinlang Weibo, a Chinese social media, and it has 2.4 million training pair and 725 testing pairs. And this is a table. This is a benchmark on LCSTS. You can see there are many methods in past, like copynet, distraction based, and minimal risk training, blah, blah, blah. And among these methods, minimal risk training is the state of the art system in Chinese. But in this state, we propose a hybrid word character model for abstractive summarization. It beats the state of the art about 8 root points. And the result is amazing. And it is easy to reproduce. So welcome to to check in and report error to us. And thank you for creating OpenMNT framework. Okay. I'm nervous.
We can ask maybe a couple questions and then we'll conclude.
Oui, bonjour. In French law, transforming text of a writer or a journalist is illegal because of copyright right. Okay? So I want to know what about this fact in USA or in Taiwan for softwares that makes abstractive summarization?
I have absolutely no idea about this. First, I'm French and I didn't knew this, but I guess people which are like they did the data set, so I guess the copyright is okay. And in my case, for French data, I will rely on private data, so we'll see the copyright in like internal.
Okay. Extractive summarization don't have problem because it's comment ils appellent ça droit de citation. Yeah. Okay. We don't transform the sentence of a writer, journalist, your text, and so on, because it's your right.
Yeah, so our idea is like precisely the opposite. We would like to reward, and because I'm not working in the context of journalism, so my point is to take a long like meeting report and to generate shorter one. And in such context, you have to reward and you have to use synonyms and to change the sentence, the whole sentence.
I'm working on summarization context, and I found this problem. They said to me, stop, I have to do just extractive summarization.
Okay, maybe that's...
In France, perhaps in USA or
okay.
You're saying
That may be a specific problem, maybe.
That's really interesting. I've never heard that before. Yeah. Huh. I gotta get out of this country quickly or they're gonna arrest me. Any other questions for either this or Sebastian's work? Okay, well, I'm going to hand it over to Jean to finish up, and let's thank the speakers.